Hi everyone, it's a beautiful day to learn. Let's study protocols and communication. In this lesson, we're going to take a look at what is data communications, understand how data flow works, understand further the importance of protocols in computer networks, and learn the elements of protocol. Again, data communication refers to the exchange of data between two or more devices via some form of a transmission. Yeah, the transmission media could either be wired or wireless. When data moves from one point to another, there is what we call data flow. Data flow could be simplex, half duplex, or full duplex, or we simply call that as duplex. In a simplex communication, the flow of data is one directional. So you have a sender and a receiver at the other end. Example, when you are listening to your favorite radio station, so your radio is your receiver and the sender is the radio station via its transmission tower. So if you wanted to make a request for your favorite song, you have to make use of other devices. You have to call, you have to post through Facebook. You cannot bark onto your radio hoping that your favorite DJ would be able to hear it. Doesn't work that way. So similarly, when you watch your TV, it's the same story. So your device, your TV, as your receiver, is only it cannot transmit. So the communication from that station back to your TV. On the other hand, we have what we call half loop. This is bidirectional, but it's not at the same time. So it's like you're having a road with only one lane in it. So when the traffic, you have to stop one traffic so that one direction would flow. Let's say you have a northbound vehicles, you have to stop the southbound. When that particular traffic is done, you have to stop that particular northbound traffic, and then you have to let go of the southbound traffic. Otherwise, there will be of sense. An example is a walkie-talkie or the two-way radio. Sometimes we call that a citizens bandwidth radio. Um, this is a two-way device. However, only one of you can talk at one point in time. The other one has to listen. When the other one is done talking, then it's the turn of the other party make a call. So there is a protocol involved there. So if you're going to make use of a radio like that, you have to make use of a walkie-talkie, then you have to follow a simple protocol, something like uh, what is Alpha 1, what is your location? Over? Over, so that the receiver knows that you're done talking. Okay? And then they will say, Alpha 1, this is Bravo, location is 123, coordinate 124. Hence. And when you say over and out, that means conversation. Okay? Last is full duplex. In this kind of communication, both parties could communicate in both direction at the same time. Your best example there is a cell phone. Once the connection has been established, the two parties calling each other be able to talk either uh, one at a time or at the same time. We move on to protocols. Protocol is a set of rules that governs data communication. As we have explained in previous videos, that all communication schemes will have something of these four. Must have a sender, must have a receiver, a message, and so the role of the protocol is to govern all these four elements that are present in a communication, whether it's human communication or computer communication. In a human communication, we have the sender, the receiver, a protocol. Yeah, the protocol says there should be a sender, receiver. The protocol says there should some form of a communication language or a common language that will be used. So again, both parties, two or more of them, should understand that common language they are using. There is communication. Next is speed and timing of the. Naturally, some people talk faster. Some people have difficulty understanding the way you talk, because problems in talk or fluent with the language, and then you have to try moderate speed such that it becomes easier for the receiver to digest whatever you are. So just like in normal communication, talk fast, talk slow, have to regulate that communication can take. Okay, and we also some kind of, we also have some kind of a confirmation, and again it is important that the sender, so, should be able to figure out that the recipient was able to receive or understand the message that was communicated, right? So when you are talking with someone, there's a way to figure out whether that person is listening to you or doing something else or understands you at all. Okay? In network communication, we have these elements: message encoding, formatting and encapsulation, timing, size, and the delivery done. When a message is transmitted, it depends on the type of transmission medium. But the bottom line, it should be converted into ones and zeros first before it is converted to its electrical form if it's a copper wire, or pulse light if it's using fiber optic. In this diagram, you could see the message source, and then it is encoded by the encoder, obviously. And the purpose of the encoder is to convert, if it's a picture, if you're sending a photo, it's to convert that photo into signal. As I've said, it could be electrical signal or light pulses, depending on what kind of transmission channel we're going to use. And then when that image or photo has been transmitted or converted into a signal, then it is ready for. So when it receives the other end of the transmission segment, the receiver, the purpose of the receiver is to receive that signal and feed that to the decoder as a signal, and that decoder will have to revert it back to its original form from ones and zeros converted to its equivalent image, and then the destination should be able to display that image, whether that is a phone or a monitor. Next is message formatting and encapsulation. So this diagram that you see here, this is the uh, OSI model. So there are 5 layers here presented. But taking a look at it, you would see when it's coming from the that other portion, other side, from the upper layer, goes down, pababa, and then it moves the next destination. So at the lowest layer, layer number 1, which is the physical layer, you can see there that uh, the message has already been converted to its equivalent ones, zero, and then eventually form. So what happens there is every layer that the message passes through, additional information is added to that raw message to make sure that the message can be delivered to its intended destination. So in layer 2, you have to identify whether the message is a TCP or UDP. You have to add the IP address that is necessary. You have to add error checking mechanism, and many more protocols that works together, make sure that the message is delivered to its intended end. For example, when you buy something from online, Shopee or Lazada, so that small item that you buy, let's say for example you're going to buy a mic, then that has to be packaged. So they have to put that in a bubble wrap. They have to put a plastic packaging, and then eventually they have to put address at the front of it so that the delivery agent would be able to bring that to its destination. So when you receive that box coming from the delivery boy, you will have you have this process which you call unboxing. So you have to remove every other additional packaging that was added by the vendor to make it sure that your package or your product that you bought will arrive at you in a pristine condition. Hindi siya basag-basag. So, you do the unboxing, so you remove the outer covering, and then inside that covering, you probably have a bubble wrap. After the bubble wrap, then you might have an extra layer of foam, and then eventually get your product. So now you see the product, and because of those mechanism that was put to make sure that the product is safe, you get a very good product as shown in the website when you right. So that's how encapsulation works, to encapsulate the product as it travels across the third one is timing. So flow control is important. So you can see if the fast computer is transmitting messages at a rate where it's faster than the capability of this receiving computer to digest or to receive those messages, then overwhelmed. The recipient will be overwhelmed. So that kind of situation where it exists. Obviously, not all computers are made the same way. They don't have the same specs. Some are slow, some are fast. The fourth one is size. If you have a very big package, if you have a very big mess, let's say 1 hour of movie or a full length movie, which probably could have a size of 1.7 gig. That particular movie cannot be transported all at once. Very big. Remember that the communication channel has limitation. The transmission channels, particularly founded, it's a physical limitation in terms of size. And that also entails some capacity. So a twisted pair cable probably could have 100 Mbps only, 100 megabits per second. So a message, when it is transported, it needs to be broken down into manageable pieces of data, which we call packet. That packet travels across the network, not necessarily in a queue like this one, but they could be dispersed and routed on their own. And when they arrive at its destination, they will have to assemble themselves together. And then finally, we have delivery options. You deliver could be unicast, multicast, or broadcast. If a delivery option is unicast, you have a sender and only one receiver among many receivers. 1:1 only. So one transmitter and then one receiver. And so if you ping computer A from computer B, then there is only one communication between computer A and computer B. It's very specific. On the other hand, you have a broadcast. A broadcast is one sender and sent to all broadcasts. So if I am standing in front of many people and when I am talking publicly, then I am broadcasting. The lesson that I am saying is heard by everyone in that class. Whether you like it or not, you will hear it. Whether it's interesting or not to you, you will hear it. And it's up to you if you would like to digest or you would like to process that message. But the point is, you were able to receive that. So when is it necessary to have a broadcast in data communication? A good example is if a new device enters a network, no? Have your phone, you went to a Wi-Fi and you wanted to connect. So when you connect to a network, you must have an IP. Where do you get that IP? In that way, you have to broadcast using that 255.255.255.255. You have to broadcast a message, meaning all computers in that network should be able to receive that message. That message would say, hey, who among you is the DHCP server? Can you give me an IP address? Because I would like to connect to. Of course, since all of those computers were able to receive it, and if you are not the server, you will not reply. The DHCP server will have to reply. And the communication there from DHCP server to the one requesting a message is a unicast. But from the one asking for an IP address, sending a message to all is called a broadcast. And last is multicast. In a multicast communication, you have one sender and it could send to multiple specific destinations. So it has to be specific. It's not any of them, but specific, but more than one. That is fast. Okay, so we have discussed the protocols and communications, and I'll see you again